This is Qt5 Design Patterns Section 5. This section deals with signals and slots. And on the surface, this may seem very basic. I mean, after all, signals and slots are the very bedrock of Qt development. We're going to deep dive into this. We're going to talk about connecting, disconnecting, the connection types, and we're going to make an auto connection class so we don't even have to connect the signals and slots. It will just happen automatically. We're going to look at child events along with the sender function and signals and slots inside of libraries. All right, we're going to take a look at signals and slots. And I know some of you out there are groaning and going, oh, I already know signals and slots. Very, very true. We're going to take a look at signals and slots, mock, and some of the code that gets generated here. So I've got some classes, and we kind of take signals and slots for granted here because you got to remember, these were created back when either there really wasn't a signal slot mechanism or it just sucked. It was like more of a callback sort of thing. So anyways, I got three classes. Producer, which will produce something, consumer, which will consume it, and the my class, which of course is just a very simple constructed, destructed, and do something with it. So let's dive into our producer real quick. Going to grab some includes. QObject, QTimer, QDebug, QSharePointer, and my class, this little guy. And let's go ahead and fill these in. So first thing we want to do here is create some slots. So we're going to say public slots, and let's say void start, and void stop. And then for our signal, we're going to say void ready product. And this is going to be a Q shared pointer of the my class. And let's just call this PTR. Now I want a private slot in here as well. We'll see why here in just a second. As soon as I can figure out how to spell the word slots. There we go. We'll say void produced. Let's go ahead and implement these. All right, and flip back one more time, and let's just put a timer in here. And you probably guessed already what we're going to do, so I'm not going to waste a lot of your time doing this. mTimer set interval, we're going to set this at every 3 seconds, and we're going to connect the two objects, the timer, QTimer's timeout signal, to this producer produced, our slot here. This is our private slot, so no one but us can see this little guy. And then I'm just going to say in start. Wow, even screwed that up copying and pasting. That's embarrassing. And then in stop. So pretty simple. We're going to say, hey, we're starting, start the timer, stop, stop the timer. And then in produce, this is where the magic is going to happen. So I'm going to actually type this out. I'm going to say qinfo this producing item. And then now I'm going to make a Q shared pointer of my class. You kind of guess that is what we're going to do. Boy, I really screwed that up. All right, equal new my class. And then I'm going to emit that product ready, or I should say ready product. And then we could just say something like item produced. That way we know we've actually done our full production cycle here and we don't need to do anything else. So now we've created this my class, and you remember our my class just simply says it was constructed or destroyed. So it's going to say constructed, and then we can do something with it. Now the producer has actually produced. We've emitted this ready product. which means we're going to have to connect our consumer to this ready product and then consume this Q shared pointer my class. All right, so let's jump into our consumer here. And I'm going to, through the magic of copy and paste, bang, Q object, Q debug, Q shared timer, Q time, not timer, Q time, and the my class, this little guy here. And then we're going to just, if we want to save just a smidge of time, we can grab this, jump back over to our consumer. And voila. Now all we have to do is right click, refactor, and bang, there we are. Now our consumer is going to be super simple. Not really focused on the producer consumer design pattern at this point. We're just talking signals and slots. So we're going to say this, and let's go bang, and consumer is working. Grab him. Really not doing anything. We're not going to grab like an Academy Award this year or anything like that. We're not curing cancer. We're just doing some arbitrary work. And we're going to say PTR test, and I'm going to say Q time current time to string. So if you're wondering what is this test, it's in our my class, and it's just going to say, hey, this object, this value right here. It's just going to spit it out on QInfo. Like I said, we are not doing anything even remotely constructive. We are really focused on signals and slots. Let's jump in here, and now we're going to connect these two objects, the producer and the consumer. So I'm going to say producer. Ooh, probably help if I actually had some includes, huh? All right, so let's go ahead and include Q object. Let's go ahead and include Q debug. Let's include producer. And let's include the consumer. Notice what we're not including, the my class, even though in our signals and slots we are actually using this. But we don't have to worry about it. We're going to let Qt take care of that for us. So now I'm going to say producer, consumer, and then I'm going to connect these objects. And you have probably done this thousands of times in your career so far. So Q object, connect, and here we're going to say the producer, and we want the producer ready product, and we're going to connect that to the consumer, and we want the ready product. Now I want to just produce this until the end of time, but I'm going to now connect our producer, or actually our core application, the about to quit signal, to our, you guessed it, producer stop slot. I like saying that, stop slot. All right, so really what we're doing here is we're saying when our Q-core application is about to quit, it's going to emit a signal. We're going to read that signal in under the producer stop, which of course will stop our timer. That way we don't have this class running in the background indefinitely. And then I'm just going to say producer start. Kind of a fire and forget solution, right? Save and run, and let's see what happens. All right, so our producer is producing, and every 3 seconds we should get something. Yep, constructed, consumer's doing, there's a time, finished, item produced, destroyed, blah, blah, blah. And it's just going to keep doing this over and over and over again until we close this program. So what is so special about that? We kind of take this little guy, the QObject Connect, for granted. when we build, what actually happens here? Let me bring up the right directory. There we go. All of this is generated for us. We have our consumer, our main, our makefile, and we have all of these, but what's this? Mock. That's right. I'm sure you've heard of mock before. Mock stands for Meta Object Compiler. So what really happens in the background here is that Qt takes all this code. Let me actually rebuild this. There we go. All right, jump up here. So what actually happens is bang, go to clean, and then mock. We're going to remove these files, and then we're going to call make. And in this process, in through here, mock actually happens. And what mock, or the Meta Object Compiler, does is it jumps in, analyzes your code, and says, what do we need to do? And at that point, these files are created, these C++ files. Let's see if I can pull one out here. There we go. And this is auto-generated for us. We don't have to do any of this. In fact, this file will be deleted. So it says meta object code from Breeding C++, and it tells us where we got it from, created by, and let me actually kind of resize this. And this is some pretty cool code if you start looking at this stuff. So it's using the Qt core, and then it's going to figure out the meta type. And this is why meta typing is so important. To be a Qt object, you have to have some sort of meta type, even if your meta type is just Qt object, so we can work with signals and slots. And then it calls a bunch of stuff, and it actually says, and you can see right here, consumer, and then you see exactly what it's doing under the hood here. Now this stuff is, well, the source of madness. If you just try to just look at this and figure out what it's doing, you're like, what? But here's the actual static meta call right here. This is what happens with the signals and slots under the hood. So do not try to really dive into this code, and don't try to go in here and start modifying it. Don't look at this and go, oh, you know what, I really feel like doing something and changing that. No. Don't do that because it's automatically generated. And let's see what happens if we clean this. Let's go back to our, and notice how all of those files are now gone. That's why you don't go in there and try to modify them. I'm going to be brutally honest with you. There are temptations to go in and try to change the meta object compilation process. Do not, and I repeat, do not try that. You will not end well. So, in short, when we build, the real secret sauce to Qt here is it takes all of like the Qt object connect and then, you know, this little macro here, the Qt object, and it does all this stuff in the background for us, so we don't even have to think about it. Just wanted to touch on that as a refresher in case you kind of, you know, slept through that day in class. But when we talk about signals and slots, really what we're talking about is mock code that gets generated for us that's called in the background that we don't even need to think about. Okay, this video, we are going to talk about disconnecting. Have you ever had a disconnect like you and your significant other just have not been talking? That's exactly what we're going to do. So, no, we're not going to get into a fight with our significant other. As funny as that would be, we're not going to do that. Instead, we're going to do the opposite of connecting. We're going to disconnect to Qt objects. And we're going to show a reason why you would want to do that. This is something that we often take for granted. We don't really do a whole lot. Honestly, I rarely find a need to actually disconnect two objects. All right, so let's look at an example of why we would want to disconnect two objects. So we're going to create a class. I'm going to make an alarm clock here. Probably shouldn't call it an alarm clock. It's more of just a general alarm. And we're going to qdebug. And then we're going to qtime. And we're going to also add qtimer. And then I want to gonna add that, and then I want to, you know what, I'm gonna stop fighting the IDE. I need to get into the habit of actually trusting things. QTime mlimit. And let's go ahead and right click, add the getters and setters in there. Let the IDE do the magic for us. Add that in there. Now we want a public slot. Somebody asked me, does it really matter like what order? Do I need to do signals before slots or slots before signals? No, it 100% does not matter. As long as what you need is where it is, you don't really need it moved around anywhere specific. There's some people that like, yeah, slots should always go up above signals, like this should be up here. It really 100% does not matter. All right, so we're going to take this, put this where it actually belongs, and we're not really going to emit any signals. We have a private QTime, and we've got a getter and setter. Very, very simple code here. Let's go ahead and add that in. I'm going to grab something off the screen here and bang, just gonna save. And then let's go ahead and I'm going to say alarm set for and mlimit. Now timeout, this is where we actually do some sort of interesting stuff here, and I'm going to say QTimer. And I want to get the sender out of this. So what we're going to do, you guessed it, is we're going to hook into a timer here, but this slot, this timeout slot, is going to be called outside of this class. So hence signals and slots. So I want to know who called me. So I'm going to say QObjectCast. QTimer. And I want that to be a pointer. Now, if we do not have a timer, something went horribly wrong, and we need to just eject right out of this. It's like in the early 1980s shows, they'd hit the ejector button and boom, you're out. That's exactly what we're doing right there. Now we're going to say if QTime current time is greater or equal to our limit, then we want to do some things, and then sound the alarm. We're not actually going to sound the alarm, but it sounded really, get it? We're not going to sound the alarm, but it sounded really good. Anyways, so we're going to sound the alarm, and we're going to say QInfo, and this is where we would do something if we were interfacing with a bit of hardware, or if we wanted to play like an MP3 or something like that. For our purposes, we're just going to display in the console, as boring as that is. Now, this is why we would want to disconnect. There's a timer out there somewhere, this guy, and he's going to keep emitting regardless of what we tell him to do. And we no longer want this to be called. So the only way we can really do that is either to ignore it, but it'll still get called, or you guessed it, disconnect. So we're going to disconnect the timer. And we want the timeout, which is what's calling us. And we want to disconnect this, and we're going to disconnect the alarm timeout, our slot that we're currently in here. So the general premise here is somewhere, which we haven't done yet, there is a timer. That timer is going to be connected to our timeout. And then every time that timer fires, it's going to do this. We're going to cast to see we actually have a timer. If we don't, we hit the eject button. If we do, we're going to say, is the current time greater than or equal to the limit we were given? If it is, sound the alarm, and then we no longer want to hear from that timer ever again. So this is the beauty of signals and slots, is that you can connect them and disconnect them and treat them in various fashions here. Let's give this a build, make sure we didn't goof anything up. So far, so good. Put some includes in here. QTime, QTimer, QDebug, QObject, QList, and alarm H. In case you're wondering how I magically get these includes, I have them in notes off the screen just to save a few minutes of typing here. All right, so what we're going to do next, we're going to make an alarm function that's going to actually just generate an alarm for us. And we're going to talk about creational patterns later on, but right now we're just doing this. So we're going to make this alarm. We're going to say alarm and we want new alarm. Seems a little weird, isn't it? Now we are going to alarm, set that limit, and we're going to say Q time, current time, and we want to add a few seconds here, and we're just going to add however many seconds they told us. In case this little bit here is giving you an eye twitch, it probably should. We could actually do this differently. Like that. I'm going to leave it this way so I don't get a lot of hate mail. All right, and then we're going to say QObject connect, and now we want to connect our timer. We want that timeout signal, and we're going to connect that to our alarm. Timeout. There we go. So that's where our connection is really happening, and then of course we are just going to return that alarm. Now, danger. What have we done? What heinous crime have we just committed? You guessed it. We have created a dangling pointer, and possibly, I should say possibly. So we've created a pointer, and we're just going to shoot that pointer out into the beyond, hoping somebody out there takes care of it. Well, yeah, I don't like that, so we're going to actually take care of that pointer because pointers scare me. They keep me up at night. So I'm going to make our timer. And we're going to set the interval for 1 second. So every second this timer is going to fire off. I'm going to say timer start. Now, and I want some screen real estate here so we can see what in the heck we are doing. Now we're going to say Q scoped pointer. You knew that was coming. Alarm. And then we want to say alarm 1. And let's go ahead and make an alarm. And I want this to be 5 seconds from now. And I'm going to give it our timer. So really what this is going to do is going to make a QScope pointer, alarm 1, from this guy, and it's just going to connect the signals and slots from the timer and our alarm object. Pretty self-explanatory here. And I want to set object name, alarm 1. Just want to see exactly what's going on under the hood. And I can actually just make that very, very easy. Let's grab this. I always miss that first letter. All right, so we're going to have 3 alarms. We're going to have alarm 2 here. And let's set this for 10 seconds. And then we want to say alarm 2. And then we want alarm 3. Very easily could have done this in a for loop. Set that for 15 seconds. Alarm 3 is going to say alarm 3 is the name. And we're done. So what's going to happen here is we are going to get rid of this blank space, or that'll annoy me. We're going to build this, make sure we've got no little gremlins. All right, nothing's going to come back and haunt us, hopefully. We're going to take a timer, set it to 1 second, start it off, and then we're going to make some alarms. And we're just going to connect the signals and slots from the alarm to the timer. Where is it? There it is, timer. And because this timer is happily firing off every second, we need to, you guessed it, disconnect whenever we don't want to hear from that anymore, because it's going to keep emitting that signal over and over again. This is actually, if you play video games, this is actually a pretty common pattern. Instead of each object having a timer, because timers are expensive, they'll have one timer, and that timer controls a lot of different objects. So I think they call it the global timer or something like that. Let's run it and see. Ta-da! It's just going to run for 15 seconds here. It looks pretty noisy because we have these timeout, 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 and then alarm. So let's clean this up a little bit here. This guy is what's making all the noise, so let's just comment him out, run that again, and see what this looks like. So we have our 3 alarms set, and then we should see alarm 1 and then alarm 2. So there's alarm 1 just went off, and then 5 seconds later alarm 2 should go off. Then alarm 3 should go off in 3, 2, 1, boom. There it goes. I got a little nervous there when I said boom and nothing happened, but you get the point here. That timer is still firing away in the background, but we are no longer listening to it because we've disconnected from it. So that's a really good example of why you would want to disconnect if you have something like a global timer and you only want to listen to that object for a certain amount of time or until a certain event happens. This video, we're going to talk about the sender function, and we often just kind of take this for granted. So let's crack open a console application. We're going to go Qt5 design patterns, and this is 5.4, and this is one of those videos I'm probably going to make a boatload of mistakes because there's a lot of typing involved. All right, so what is the sender function? Well, it is the object that emits the signal. So we're actually working with this in the slot, and you've probably, I hope, you have seen this and used it and understand it, but I wanted to give a good solid real world example of why you would even need this, because a lot of people just kind of ignore it. So we're going to add networking, which we just did, and then we're going to go in and add a new class, and let's call this server. It's a Q object. And once it generates the code for us, we're going to go in here and we're just going to copy and paste some includes, QObject, QTCP server, and QTCP socket. So we are going to make a simple TCP server. And when I say simple, this is basically going to be a mini chat server. So we're going to flip back here, right click, and I'm just kind of going through really quickly a lot of just the basic stuff that you should probably already know for this course. It's assumed that you've already made a few TCP servers in your time. All right, so what we're going to do next is we're going to look at 2 different ways of doing this, 2 popular methods. The first one is we're going to hold a list of clients, or I should say a list of pointers to clients, and the second one is working with the sender function. So because we're going to be holding pointers, RAII, we need to actually make sure we get rid of things when we don't need them. All right, so make our deconstructor, maybe, if I could type. Don't you ever hate it, like when your keyboard's just a little bit off center and it screws you all up and you're like struggling to just do basic things? All right, so got our constructor, our deconstructor, and then I'm going to go ahead and go here, say private. I'm going to make a Q list of Q TCP. Wow, I am way off. Sockets, and these are going to be pointers, of course, called mClients. And then I want a function, which is going to just, you guessed it, send to all the clients. We just want a string value of some kind. And then I want another function, maybe, there we go, QString, and I want to get the client name. So the premise here being, when people join our chat server, we're going to ask them for a name. We're going to store that in the object name of the socket, and that name is who they shall ever for be known as. And let's go ahead and implement these. All right, so far, not rocket science. Incoming connection, a list of clients, and 2 functions. We're going to also add in some slots. So I'm going to say and I'm going to copy this straight out of Qt's documentation for the Qt TCP socket. The socket's going to emit a connected, a ready read, and a disconnected. So why are these public? Doesn't need to be. They could be protected, they could be private. We're really the only ones that are going to be using it. So let's go ahead, flip there. I'm just allowing it in case I wanted to use this class later on and say, hey, want to use something outside. And when I say outside, I mean outside of this class. So, all right, so we are going to close the server down when the server is destroyed. And let's go ahead and go with just want to check something super quick here. Nope, not in there. All right, good. Wanted to make sure I wasn't doing something incredibly dumb, which I probably am. Usually I do something dumb, but all right, so we're going to say we have a list of sockets, and when the server's destroyed, we want to close the server down. And at what point we want to say, okay, close that down, and I'm going to do a for each. And I'm going to say QTCP socket object in our clients. And then I'm going to say socket close. And so we don't have any dangling pointers out there. I'm going to say Q delete all. And we're just going to let Qt take care of the memory management for us. So any sockets that are sitting there, we're just going to say bang, close them all, delete them all, clear them out, and then close the server down. And from here, our life actually gets a little bit interesting. So we're going to say incoming connection. This is where the socket comes in. And I'm going to say Q TCP socket. And somebody out there is probably saying, why aren't you using automatic memory management? Why aren't you using like a shared pointer or something like that? I just simply don't want to be brutally honest. There's a billion different ways of doing this, and I'm just showing one specific way. The way that I'm showing is, I think, a little less cumbersome by using the Q delete all, but yes, you can absolutely use Q shared pointers or the standard library automatic pointers. All right, so we're going to make the socket. We're going to append that socket into our list on the incoming connection. And then because I absolutely detest making connection codes, we're going to connect the socket connected to our connected and ready read to our ready read, and disconnected to our disconnected. And if we were not concerned with students skipping videos, we would have used the auto connection class that I made in a previous video that would have automatically connected those signals and slots. So socket, I'm going to set the socket descriptor, which basically tells the operating system, hey, we are now taking ownership of this. And then I'm going to emit the socket connected. Now, why am I doing this? Why am I emitting a socket connected? Because when we accept this incoming connection, the connection's already been made. The operating system's already said, hey, we accept this. Now, it might not have done it completely on the TCP stack, but the socket itself thinks it's already connected, so it won't emit that. Kind of confusing and frustrating when it does that. All right, so the other reason is we have our socket connected to the server connected, and it's going to call this guy right here. It'll never fire off if we don't emit it. Now down here, this is where we actually play around with sender. I'm going to say Q TCP socket, and I'm going to say Q object cast. Oops, not send all, sender. There we go. As funny as that would be, we're not going to send all before we even have the object. And then we're going to say if not socket, then we're going to actually return out of here. Very, very simple code. You've probably done this before, but what are we really doing here? We're saying, hey, give me the object of the sender and make sure it is castable to a QTCP socket. We're not even saying that this has to come from inside this program. This could be a socket from a different class. It could be a pointer off a different program, which gets into a vastly different conversation where you're just grabbing a memory location and then sending that as an integer, and then the other program makes a pointer and points to that memory location. Not always possible on every operating system, but some of them let you do that. So Q byte array, data, and I'm going to say enter your name. And then we're going to say socket write, and we want to write that data. And I'm not going to do any like socket wait for bytes written or anything like that. I just want to fire it out and forget it. And because it's a pointer, I don't have to worry about it going out of scope or anything like that. Now, you may be sitting here going, no, wait a minute. Hold up. We've got the socket already in our clients list. Why are we getting it out of this? Well, we have to do that either way. We have to know who sent it to us. And then we could, if we wanted to, make sure, like, you know, M clients contains socket, blah, blah, blah. We could do something like that, but honestly, I don't really care. If we have a connected socket, I want to make sure I can talk to it. Ready read, just going to grab this little bit here, make life a little bit easier. And I might just do the same for disconnected. All right, so ready read, we're going to say Q byte array, value, and I want the socket read all. And we could do some other checks here, like, you know, is the socket open? Is the socket readable? Things like that. If we were writing vastly more complex code, we would do something there. All right, so now I'm going to say QString line, and I want to say value trimmed. That way, if they just entered a bunch of nonsense, or if we have a trailing line refeed hard return line feed, it gets rid of that. Now, this is where we're going to do some sort of logic. I want to say if the socket's object name is not set, then they have not really entered their name yet. So there's not a whole lot we can do here. So I'm going to say socket set object name is going to be the line. So this is, we're assuming they've connected. We've already shot off the into your name and they've responded to that. And now we're going to take whatever they typed in and just set it as the name. Whew, a lot of explaining there. All right, so QString data equal client name. And we're going to get the client name of that socket, which should be down here. We haven't filled out yet. So let's make a quick detour down here so we know what this is doing. And we're saying if not socket return QString of unknown. So we don't know who that person is. Otherwise, we're going to return the socket, you guessed it, object name. Really simple, very, very rudimentary code. Yes, in case you're wondering, this clients list, we could, instead of storing sockets, we could store some sort of class that represents the socket or the client state. For example, name, you know, password. I wouldn't store the password, but, you know, name, password, nickname, how many minutes they've been connected, that sort of stuff. All right, anyway, so back down here, we are simply going to say data.append, and we're going to say that person, whatever their name is connected. And we're going to let everyone know Man, I cannot get that today. There we go. Connected. Sometimes it's the simplest things that really screw us up. And then we're going to send all, and I want to say data. And we have not fleshed out send all yet. So let's jump down there so we know what this is doing here. We're going to say the value, and we're going to append that with a hard return line feed. Say cute byte array, and I want to go data value dot to UTF-8. So really all we're doing is just converting that string into a UTF-8 encoded byte array. And then I'm going to just every single socket for each in our clients list. And here's where you would do some sort of like, make sure it's not in the process of disconnecting or something like that. You're just going to simply say if the socket's not null, we're just going to write that data out. We could do that in one line if we really, really felt like it. So that's what send all is going to do. It's going to go through our list of connected clients, and if they're in there, it's just going to say if it's not null, shoot out whatever data we gave it, and put a hard return line feed at the end of it. All right, back up here. I know I keep sidetracking, but we're almost done. If the object name was already set, then I want to say get their name, and then I want to data append, and I'm just going to do a little dash there, and then data dot append the line, whatever, not lane, line, whatever they sent us there. And now I want to also send all that data. So the logic here is pretty simple. Somebody connects, it's going to say enter your name, they enter something that forever becomes their name. And then after they type something else, it will get sent to everyone. So it's just a mini chat room basically. All right, so disconnected, we are almost actually done with this server here. Man, we whipped right through that. Disconnected, this is where we want to actually say, all right, mclients remove, and I want to remove one. You could like remove all or whatever you want to do, but I'm just going to remove one because there should only be one. Remove one of those sockets. And then I'm going to say, very simple, I'm just going to copy and paste this because it's super easy. Bank. Now this is where you're kind of going, whoa, wait a minute here. Client, remove one. Doesn't that delete the socket? Nope, it doesn't. It just removes it from the list. So that socket's still out there somewhere. And this is where we have a bit of a memory leak issue. Now, knowing that's a memory leak, what we could do is something like this. Delete later. And that tells Qt, hey, you actually created this, delete later, which actually schedules the object for deletion. And what that will do in the background is say, okay, Qt, you have a rough idea, it's not a guarantee, but you have a reference count of where this object's used, and when it's no longer used, go ahead and delete it. I've had problems with delete later in the past, especially with TCP servers, where Qt thinks the socket's no longer in use, and well, guess what? It's still in use and it crashes the whole system. So the only time I'll call delete later is when I am, beyond a shadow of a doubt, not worried about this socket screwing anything up. The problem here is disconnected could come at a very bad time, meaning we could get this disconnected signal, but there was still data on the pending socket, like something weird happened with the TCP stack and it says disconnected and then you receive data and then bang, your program dies. Now, obviously that's not the way things are supposed to happen and it's rare, but I've actually seen it happen and it really just made me mad when it happened, to be brutally honest with you. I sat there for like an hour trying to figure out what was going on. All right, so we've got a good build here. Let's go ahead and jump over to our main. And we may have some small bugs that we need to go figure out, but I'm fairly confident in this so far. So say include QDebug, and let's go ahead and say include our server. We're going to go ahead and make an instance of our server, and we're going to say if not server.listen, and we're going to listen on Q host address any, and I want to listen on, I'm just going to choose port 3924. Hopefully that's not colliding with any sort of application or known virus or anything like that. So if we can't listen, I want to say Q critical, and I'm going to say server error string. I love the fact that Qt did that error string. I don't have to call any fancy API calls or last error or any nonsense like that. I say, hey, tell me what went wrong. Otherwise, we're going to say the server is now listening. All right, so let's give this thing a whirl. I'm going to give it a good build, make sure we didn't goof anything up. Give it a run. Server is listening. All right, so let's bring up Telnet, and I'm going to actually move this off to the side. This is our server here. Here's our client 1, and I'm going to say Telnet and 127.0.0.1. That's our local loop back. 3924 is the port. Enter your name. My name is Brian. Brian has been connected. Now, so what we're going to do next is we're going to open yet another. Probably because I have the wrong port. Ah, yes. 3924. Silly me. Enter your name. There we go. Let's say this is Tammy. And you notice how over here it says Tammy's connected. So now I'm just going to drag you over here. And so there's Brian, there's Tammy. See if I can kind of scooch these over so we can see them. You know, so it says, Tammy says, hello, I'm Tammy. And then Brian says, hello, Tammy, I am Brian. And it just works. So really what we have here is a very rudimentary server, but we've demonstrated senders along with signals and slots. And I'm going to close this guy, bang, and we can see that Brian has disconnected. Now, what's happening under the background is a whole lot of memory management. And we could do some fancy things like, you know, hook in a about to quit into server close and things like that, but you get the general principles here. What we're super focused on in this video is, again, the sender function. This guy. We often take him for granted, so some key takeaways are the sender is going to give us a pointer to a Q object. It's up to us to make sure through QObjectCast that that object is the data type we're expecting and that we can do something with that. Now, in a real world application, what I would probably do is, for example, on connected or something like that, I would actually say, you know, like clients. Now that we have a socket, I would say like, if not clients dot contains the socket return. That way, if, you know, the newbie in accounting who became a programmer who thinks he's going to do something super cool tries making a connection through, you know, signals and slots and tries sending his socket from another class altogether into the server, it doesn't blow up the server. The other main takeaway here is memory management is not always crystal clear when you get into Qt. You may have to backbone into things like the very rudimentary Q delete all, or if I can find it, socket delete later, or actually Q object delete later. Okay, this video we're going to talk about signals and slots with their connection types. And if you're an expert in this, feel free to skip this video, but there's some people out there that may not have ever really used a connection type, and maybe, you know, you need a little bit of encouragement or you need some foundational knowledge here. So I've got some code written. We've got this my class, and it's a very simple class. So I didn't want to waste a lot of time going over it, but it just simply has a constructor of a QObject parent and a name and then it's got a function along with a signal and a slot. We can actually switch in here. And so we're just setting the name in the constructor. The constructor just says destroyed. And notice how all these say qthread current thread. We want to know what thread these things fired off on. So perform is just going to emit a signal called test. And onTest is actually a slot, and it's going to be the consumer of this test. So we're literally going to make two objects called myClass, and we're going to hook the test from object A to onTest of object B, just so we can play around with these things. Now when we flip into the main, super simple. We have a test function which is going to take a myClass, this guy, that is a source, and a myClass, again this guy, which is the destination, two of the same object, and it's going to connect them using the Qt connection type. And by default, it's going to be the Qt connection auto connection, which is normally the default anyways. And we also have this little thread in here because we're going to move these to two different threads and see what happens. And that's what's going on right here. So first and foremost, we're going to take the source and destination. We're going to connect them using the connection type, and we're going to go over the connection types. And if there is a thread, we're going to take that destination and move it to that thread. And because we're doing the move to, we have to make sure that this destination does not have a parent, or it will give us some sort of error. And then the code is dead simple. I didn't want to waste a lot of time writing code here. So we just have the myClass source, the myClass destination, and they're named source and destination appropriately. The current thread is being named main thread, and this is the thread that main is running on. So this is our main thread of execution. We're then creating a second thread, and we're calling that separate thread. We're not doing anything fancy, like we're not connecting the A about to quit to the thread close or any thread quit or anything like that. We just want to see how the connection types affect the signals and slots between two objects. Now, if we pull up the documentation, there is the auto connect, direct connect, Qt connect, I should say Qt connection, blocking Qt connection, and unique connection. This is fairly interesting, and they've got some pretty decent documentation. So auto connection by default is a direct connection. What? So then why do we even need auto connection? Why shouldn't they just use direct connection? Anyways, really what it says is auto connection, if the receiver lives in the thread that emits a signal, direct connection is used. Otherwise, Qt connection is used. Meaning if these are on two separate threads, it's going to go between direct or Qt. Now why is that? If we look at direct connection, the slot evokes immediately when the signal's emitted. So it doesn't even wait, it just says, boom, I've done something. But if they're on two separate threads, Qt connection is the way to go. And Qt connection is going to say, the slot is invoked when the control reaches the event loop of the receiver's thread. So you have two threads, A and B. Thread A says, hey, I'm doing something. And it puts it into literally a queue of, I'm guessing, pointers of signals that have been emitted. And when the receiver's ready, because the receiver lives on thread B, and thread B may be asleep or busy or doing something, but when that thread becomes available and ready, it's going to read all those queued up slots or queued up signals and say, okay, let's go ahead and process all those, and then it calls all the slots. Whew, that's confusing. It's confusing because threading is a nightmare when it comes to cross-thread communications. And the reason why we're making this video is whenever somebody comes to me and says, well, I have an object on thread A and I have an object on thread B and I'm trying to do this and I can't figure out the mutex locker and this and that, I say, why are you doing any of this? Just use signals and slots. It's literally what it's designed for. And they have all these connection types. So let's go ahead and play around with this. So auto, remember, source and destination are on the same thread because we do not have a connection type or a thread yet. It's just going to backbone to the connection type auto, and the thread is going to be null. So both of these are going to be on the same thread. Let's put it that way. Let's run this. Works as expected. All right, close. Direct connection, same thing. Source and destination, same thread, but we're going to use the direct connection. Remember, direct connection is going to fire off immediately. So same thing as auto because they're on the same thread. Qt connection, a little bit interesting here. Source destination on the same thread, but we're using a Qt connection. So because it's using the same thread, it's just going to fire off immediately. Ta-da! Works. And this is the simplicity of signals and slots. And this is why I kind of scratch my head when people say, well, why shouldn't I use, a callback or some sort of weird memory construct or do some memory mapped file? Just use a signal and slot. Anyways, blocking Qt connection. This is dangerous. Whenever you see the word blocking, always be fearful. Why? Because this will deadlock. And let's flip over to our documentation here. Blocking Qt connection, same as Qt connection, our buddy here, except that the signaling thread blocks until the slot returns. What does that mean? You have two people, let's say you and Bob, and you and Bob are having a conversation. And you emit a signal and say, Bob, go do something. I'll wait. And that's literally what happens. The signaling thread waits or blocks until the receiver, in this case Bob, goes and does whatever we tell him to do. This is super dangerous because you can actually block your thread, and that's why programs stop responding. The connection, it even says, the connection must not be used if the receiver lives in the signaling thread, or else the application will deadlock. And they do have a little bit of what I call training wheels in here, meaning they try to save you from yourself. Doesn't actually kill our application, but it says Qt deadlock connected while activating, so it actually skips right over that. So whenever you see the word block, you got to ask yourself, are you doing this the correct way? And then unique, we can actually use unique on its own. It's really not designed to do that. Basically what unique is for is if you want to make sure that connection is, well, unique. It does what it says it does. It says this flag can be combined with any of the above connection types or using the bitwise or when Qt unique connection is set, QObject connect will fail if the connection already exists. Meaning you want to make sure you're not making multiple connections to the same thing. So for example, if I were to just grab this and I were to go in here and let's say source, destination, and let's grab this unique connection. So we've got the QObject connect and the source, destination, once the IDE catches up with what we're doing. And let's make a bunch of these. There is a method to my madness here. So we've got a bunch of the same object and the same destination, same source, same destination, same signal, same slot, but we're using the Qt unique connection. What happens? Nothing, really, to be brutally honest, because we haven't done anything. So let's go ahead and go emit source, and let's say test. Let's go ahead and emit that bad boy manually. We're just going to force it to go off. And then it says test from. Now you notice how we've got a bunch of these. Scroll back up. We've got a bunch of these, but it only fired off one time. Now let's go ahead and do auto connections here. See what happens. My keyboard has betrayed me. There we go. Again. Why are you like this, keyboard? Notice how it fired off a bunch of times. So that's really what unique connection does. The documentation sounds super scary where it says will fail if the connection already exists. So will fail seems super scary, but really all it does is it makes sure that we don't have that fire off multiple times like we see here with the auto connection. So when in doubt, if you start seeing something's firing off multiple times, just add in the unique and you're good to go. Now comes the interesting bit, threaded. So we're going to do the same tests, auto threaded. So here we have source, destination, our auto connection type with a thread, and this is this separate thread. And let's see how this works. Now notice how everything just works beautifully. This did not used to be the case. With older versions of Qt, you had to actually tell it, don't use a direct connect, use a Qt connection. But if you start running into problems, like if you're firing off your signal and you're using auto connect and the destination's just not get it, switch over to a Qt connection. But here in our test case, everything worked fine. But you can see it's destination test, blah, blah, blah on separate thread. And moving along, direct connection. This is where we're going to have some issues here. So you see how we've got source created on thread, destination created on moving to, and then source emitting signal and destination. Here's our problem. The sender is 0, 0. So we still get the signal, firing off our slot, but that sender is now null. It's 0, 0. So if we were to try to say, hey, cast this sender, blah, 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 it's not going to work. And that's because we're doing a direct connection cross-thread. That will get super frustrating if you try to take non-threaded code and move it to threaded code. And that is why they tell you in the documentation pretty much just rely on auto connect. But if you want to tread where no one wants to go, all these other things exist. And these things exist because auto connect didn't used to really act that way. Qt connection works exactly the way we expect it to because auto automatically detects whether it's single or multi-threaded. So when you see direct, think single. When you see Qt, think multi in terms of threading. And voila, works exactly like we think it would. Blocking. Remember, when we see block, this can be a bit dangerous. Even with two different threads, it can be a little dangerous, but for our test, it worked beautifully. But what really happens here under the hood is a bit scary. So the current or the main thread will go in here and it will call this, and then it will immediately block until that is emitted. When I say that's emitted, we're actually talking about the code in here. So if I were to say something like qthread current thread ms sleep and something like this, or even longer, just to make it painful, and flip back, let's test this and see what it does. So 1, 2, 3, 4, bang. There it goes. So that's what I mean by blocking. You can do some really bad things if you're not expecting this to block and you have blocking in there. Really, really bad things could happen very quickly. And last but not least, unique connection works as expected, even cross-thread. So the real main takeaways from this is you probably fell asleep during that day of class when we were talking about the connection types. Usually I'll trust auto connection, but if I start seeing issues pop up in a multi-threaded app, I will switch them all Qt connection without even missing a beat. I will just stop trusting auto and switch over to Qt because something underneath the hood with Qt is not detecting that it's on a different thread. Although I will admit the last 5+ years, things have been pretty rock solid in that respect. Blocking Qt connection I almost never use just because it's so dangerous and it does block your sending thread. But if you want a cheap, easy way of saying do something and wait for the other thread to do it, that's how you would. I don't like doing it though. And unique connection keeps multiple connections from occurring, which, like, if you, let's say, every time you say hi to Bob, he's going to save up $1. And you say hi to Bob 20 times, and at the end of the day, Bob has $20, and you only meant to pay him one time. That's what unique connection does. It makes sure that you don't create that connection every single time. So in a nutshell, those are the connection types. Main takeaway here is pretty much trust auto connection, but if you run into issues, switch over to Qt connection. Rarely use blocking Qt connection because of the dangerous consequences. And while I personally don't really find a need for a unique connection, it does have its special use cases. This video, we're going to talk about signals and slots to and from an application to a library. So we're going to say new, and we're going to say other projects, subdirs, and we're just going to make a blank subdirectory project. So we're going to say Qt 5, design patterns, and this is 5.6. And finish and add subproject. Now we're going to go to a console application. Let's call this my app, and I'm just whipping through this really fast. It's just assumed you already know this. And once that figures that out, then I'm going to go File, New. Actually, I'm going to right click and go New Subproject, just faster that way. I'm going to go to Library, and then I'm going to go to C++ Library. And let's call this mylib. Next. Next. And this is going to be a shared library. This is where people get a little bit confused. We don't want a Qt plugin because, well, we're not plugging into the Qt system. We don't want a static link library because we're not doing a static build. We want a shared library. And this would do, well, exactly what you think it would. It would make a library, an SO, a DLL, what's it called, a dynlib on Mac, those kind of things. So this is going to be called mylib. There's the header, there's the source, next, and finish. Okay, let's go ahead and go into our projects file. There's a little bit of surgery we need to do here. We want to make sure that our library is built before the application. So I'm going to say config plus equals ordered. And then we're just going to grab him through the magic of copy and paste here and move him up. And what that really is going to do here is it's going to say build this one first, then build this one, not the other way around. So that's what ordered really does. All right, so let's go ahead and give a good build, and that's going to build both of those out. And let's jump into mylib here. Now, it's assumed that you've already made libraries before, but just in case you haven't, we've got these two header files, the mylib globals. This is what makes the definitions, or does the defines, to export or import our actual class. And you can see how it says class mylib export. If you're wondering where it's getting that from, it's right here, mylib export. And it's going to do a qdecl export or a qdecl import depending on how it's being used. So if you're exporting or importing, and it gets into these weird, if you're not an expert in C++, it gets into imports and exports and what symbols you're going to export. I'm going to say this very badly. If you're wondering what a symbol is, every function, every member variable, everything you can imagine has a symbol inside of it. I've said that very poorly, but it tells in a very easy manner where those symbols are. So we need to tell it, take anything that's flagged with the mylib export and export those symbols so they are usable in other applications. I should actually make a class on that because it's way more in depth than what I just said. But all right, so we're going to take some includes, QObject, QTimer, QTime, and I'm going to say class. Notice this is not a QObject, so we're going to convert this into a QObject. And in doing so, we of course need to do some brain surgery here. So I'm going to say QObject parent not done yet. Out of line definition. What did I goof up here? I'm sure I did something wrong. Ah, yes, we haven't finished this yet. So I'm going to say explicit mylib QObject pointer parent. And this is going to default to a null pointer. Not done yet. We need to upgrade this using the macro to a QObject. Still not done. Ta-da! Now we are, for lack of better terms, a QObject. Let's give this a build just to make sure. If we're super paranoid, we can right click and rebuild just the lib, make sure everything builds the way we expect it to. But now this is actually a Q object, and it can have signals and slots and things of that nature. So let's go ahead and say looks like I screwed something up. I looked down at the keyboard and I was looking at my fingers while I was typing, and boy, should not have done that. All right. So we've got some signals there, and let's go ahead and say public slots. Again, looking at my fingers while I was typing gets me every time. That's one of the little challenges about doing these live unedited videos is I make a lot of typing mistakes. For example, sloats. There's no such thing as a sloats. And if there is a sloats, I don't think I'd want sloat in my code. All right, so void timeout. And then private, we're going to make a queue timer. All right, now we just need to implement our slots, not sloats, slots. And there we go. Let's give this a build, make sure I didn't miss anything. All right, good. Go into here and let's say we want to set our interval to 1 second. We're going to go ahead and go connect our timer. And really all we're doing is we're just building a class out that's going to, on, you guessed it, a timed interval, emit some sort of signals, and then we're going to consume those in our application. So we're just connecting up our timer. When we start, we're going to say mtimer start, and then we're going to emit started. And then you guessed it, we're going to do the exact opposite and stop. We're going to say mtimer stop. And let's go ahead and go to emit stopped. Timeout, we're just going to emit triggered. We could have done this, again, a billion different ways. I'm going to say current time, toString. Really nothing fantastic about this. All right, so let's go ahead and give this a good rebuild. We've got some delicious little libraries that were just created out here, so we're good to go. Now on Windows and things like that, you're going to see it'll be a different naming convention, but as long as you have a good build here, you're good to go. Say, ta-da! Windows is DLL, Linux and it's SO, and Mac, I think you can do either SOs or dylib or something like that. I'm not an expert in Mac, but that's the beautiful part is I don't need to be because Qt does a lot of that for us. So what we're going to do next is we're going to go into our My App here, and I'm going to actually collapse that so we're not even thinking about this little library here. I'm going to add a new class, and I'm going to call this client. Because we're working with signals and slots, we need a Q object to work with. So this client is going to consume the signals and slots. So I'm going to, before I go any further, I'm going to right-click our application. I'm going to go Add Library, and I'm going to add an internal library, meaning a library internal to this project. You can add an external, a system library, a system package, but I'm going to do an internal, and of course the library I just built. I want to be able to import this for Linux, Mac, Windows as a library, not a framework. And I'm just going to basically leave everything as default unless you really want to play around with this stuff. This tells us what it's going to do to the project file of our application. And go ahead and hit save. The really important bit, assuming you've done this before, but just in case you skipped that day of class, this is the project file for our application. It added this little bit in here which tells it, hey, this is how you find the library, because all this code we want to be able to work with. And then we have an include path and a dependency path, and it says the working directory, going to go up and then go over to this mylib folder. Close that. And what I like to do is just give it just a second, because sometimes it pops up and says building or thinking. And then I go in here and I build the application. And if you have any sort of, symbol not found or linker not found or instruction not determined or any sort of weird error message, 99% of the time it has to do with a path issue of looking for where that lib is. Whew. All right, enough of that. Let's go in here and let's go client. I'm going to add in Qdebug, and I'm going to import the mylib, and I want the mylib global, and I want the mylib h. So this does really two things here. It actually goes in and we're just reusing these header files. We could have added them into our project directly, but it's just reusing them. We need the globals because it has this little guy here, and our H file has our class header. So we can just close that out. As long as you don't have any red squigglies and it can find it, you're good to go. But usually I like to give it a full build just in case. You notice I'm building a lot. I get a little bit paranoid here. So we're going to say void start, void stop. Now I want a signal. I'm going to say void limit, some public slots. Really don't need to be public. And I'm going to just copy and paste these from that header file. Started, stopped, triggered should look very familiar from our lib because it's the exact same thing. And from private, I'm going to say mylib, call this underscore mylib, and then int mcount. So really what are we doing here? Simply making a client, which is also a Q object. It has some public functions along with some slots, and it has a signal, and we have a mylib from our library along with this little count guy. All right, so let's go ahead and flesh in our slots. And just in case you missed it, we're going to do the old copy and paste here. Signals and slots work as expected. Ooh, what is this? Undeclared identifier. Mylib. There we go. For some reason it doesn't like that. Spelling, that's what it is. My notes are different. My notes have betrayed me. Easy fix. Case sensitivity. All right, so we're just connecting the signals and slots. So we're going to connect our mylib object started to our client started, and then stop to stop, triggered to triggered. And then we're going to say this limit to the lib stop. So once we hit a limit, we're going to actually tell that library to stop. Whew, pretty simple code. Just a lot of talking, and I absolutely hate making connection code, this stuff. That's why I prefer to just copy and paste it. And then I'm going to say mylib, and we're going to go ahead and start. And calling signal, I'm not going to put that in there. I was going to explain something totally different, but not going to go there. And then for stopped, I'm just going to go bang, bang. Stop. And then I want to say we're missing some stuff here. That's why I have this backwards here. Mistakes have been made. I'm very sorry. All right, let me fix this super quick. I thought that looked really, really funny for a minute. That's why it screwed me all up. So, all right, let's fix this. This should make a little more sense now. Gosh, how embarrassing. All right, so start is going to start, stop is going to stop, and then on our slots, we're going to do something different. So when we are started, we're going to say QInfo. See how easy it is to get all screwed up. And the old copy and paste here. Then for triggered, I'm just going to say mcount ++ if mcount. Did I miss something? I did. So if count is greater than or equal to 5, then I want to say, hey, we have hit our limit. So I'm going to say emit limit, and then just return out of here. Otherwise, we just want to go in here and say QInfo, what are we currently on? And let's go ahead and print that value out. And we could put the count in here too if we really wanted to. That way we see exactly what happened. So I'll go ahead and give this a rebuild just in case. Whenever I work with libs, I get super paranoid because I've had Qt kind of betray me before. I shouldn't say Qt. 99% of the time it's my own dumb fault, but I blame Qt. There we go. So what are we talking about? Signals and slots inside of a library. Works great across libs. Sometimes people become a bit confused about libs. You saw me get a little bit confused, but that was more just me being dumb. Want to make sure we have a mylib and a myapp and do that config ordered. And then we're going to add that library like we did. So what we do from here is very simple. We're just going to test this out. Going to make our client. I'm going to say client and client start. Very simple, very easy. Give it a build, run it. Started, and there we go. So we've got signals and slots operating across a library. This is insanely cool. So what this means is you can take your Q objects and put them in a lib, and then from there, just use them however you need them. The only real catch, I don't even really want to call it a catch, it's more of a mandatory requirement, is anything you want to use, you're going to have to export. Otherwise, you just will not see it in your calling application. But again, we're talking about signals and slots inside of libraries. And as you can see, they work just beautifully. They work exactly the way you would expect them to work, as long as, unlike me, you spell it right. But there's really no extra magic you have to do. As long as you're talking from one Q object to another Q object, everything just works beautifully.